So we've covered a few things already with the periodic table. So just to go back and review those things, there is the periodic table broken up into the S block. This one's a little bit of an exception, often floats up there. And so we got the S block, D, P, and F blocks over here. Just included the pictures there of the three-dimensional wave equation derivations of where the electrons are going to be, so they can stay away from each other as far as possible. And if you read across, that's how you get the electron configurations in the lowest ground energy states there. We got the 4 principal energy levels. So if you add up all the 1s, 2s, 3s, and 4s, and so if you read these out here, so you got 1 here and you got 1 here. So that's 2 electrons in the first principal energy level, 2 there, 6 across here. So that's 8 in the second principal energy level, 18. We got 3s 2s over here, and then we got the 3p 6s, if you fill that whole thing up, and 3d 10s. Okay, so that adds up to 18. And then it drops a little bit here. So 4s2, 4p6, 4d, where's my pen? 4d, and then we've got the 4f. There's 14 in there and 10 up there. So that all adds up to 32. So they're the principal energy levels. It's getting a little bit dangerous down here because we've got convergence, we've got overlapping and all sorts of stuff going on down there. So it gets very, very messy once you get past the third energy level, really. Okay, and so that's just stuff that we've covered in atomic theory. And there's just a few other things to cover for the periodic table. So first of all, the line between metals and non-metals is a little bit difficult to know. So the metalloids and semi-metals, I just go down 2 and don't include aluminium, and then just drop 2 each time. And that's the magic line without including aluminium. So all things to the right of the periodic table from that line are non-metals. So insulators of heat and electricity, brittle, dull, these things. As we'll go with periodic trends, you'll see why they like to gain electrons to get a full shell, because it's very easy, and it's on that slide there. And so that is reduced, we say, once you get to redox. And the metals like to lose electrons, and we're going to call that oxidized once you get to redox. And so the metals are good conductors of heat and electricity, easy to bend, draw into a wire, and shiny as general principles of the metals. So everything on the left-hand side of that line. And so if you go into some more things that you need to know before we can get into periodic trends, so they increase by 1 proton each time. So they're in order of atomic number. Because they're atoms, in this case here, the electrons will be the same. And so everything here in one group will have the same number of electrons in the valence shell, so same valence electrons. So there's one electron in the valence shell, so they'll have similar chemical properties because they'll all want to lose that to get a full shell and become 1+, okay? And these guys here all have 2 electrons in the valence shell, so they're all going to become 2+ ions, and so they'll have similar chemical properties because of that. And so that is that's the relation with the groups, all similar chemical properties. For periods, we're generally in the same principal energy level, and so they're all the same distance from each other. So they also have the same amount of electrons blocking it, and the same distance. All those electrons are the same distance to the nucleus. And so we'll use that to describe some various trends. Now, the last thing you need to know is the blocks. We've already tried to work out how to work out where that magic line is. So of the non-metals, the noble gases are unreactive because they have the full shell that everyone wants, and the halogens are the next line over. So if you recall, those things are the diatomics plus the halogens plus hydrogen. So they're the ones with the H2s, N2O2, F2, and all these guys are 2s. And these guys obviously are very reactive because they just want to gain 1 electron, so 1-. So the alkali metals, or the group 1 metals, are this first one over here. Okay, hydrogen's an exception to the rule. We'll ignore that. And the last thing is the transition metals, which are the bit in the middle. And once we go over transition metals in a bit more detail, you'll realize why we have not included those ones there. Okay.